There is a relationship here between the fascia and the digestive system. And even though it's not a direct relationship, they communicate and they react to one another. And this is worth mapping out and understanding if we want to help some people. When it comes to the fascia, and we'll say this is fascia. Woo, look at all that stuff. Maybe that's some fibroblasts in there. There is a lot of sympathetic innervation in fascia. That's sympathetic nerves going to the fascia. What that means is the spinal cord sends off a whole bunch of nerves to our fascia, or major connective tissue areas. And these have little nerve endings on the end of them, and they are sensitive to changes in that fascia. If they're sensitive to it, you would think it means that sympathetic system, that fight or flight system, wants to be aware of what's going on in that fascia. One of the things it happens to be aware of is the strain and immobility of the fascia. These two factors actually play a good role in what activates that sympathetic system. Now, interestingly, both of these are completely interrelated, one causing the other in kind of a never-ending loop, should you give it the ability. That's a story for another time, though. In any case, this forms an afferent, an input into the sympathetic system. It will be what's read by the sympathetics, and that means it should have a reaction to it. We call that reaction an efferent signal. With an E, not an A. Efferent, that means effect. So this would be the effect of the sympathetic system reacting to that strain and immobility. And there's a good reason for this. Strain is exactly what you think it is a pulling of the tissue apart, and it usually indicates some kind of a damage has happened. So maybe a piece has separated from another, maybe it's torn. There's a good deal of pain when this happens, even if it's low level. Even in an isolated way, even in a very small part of it, there's still a little bit of low-level pain, which should cause a little bit of fear. It should cause a little bit of activation of our fight or flight mode that we call the sympathetics. Immobility, on the other hand, is also exactly what you think it is. It is not moving at all. And this is very dangerous for living tissue. It wants to move within a certain range, at a certain amount, at a certain time, but it is still important. So both these things will turn on the sympathetic receptors. It will turn on these little bits in the sympathetic system that will read and cause a reaction to that change in the sympathetics. The most normal thing for the efferent to do, for the reaction of the sympathetic system, is to change blood flow. It directs more of it to certain areas. Some of those areas include the muscles or musculoskeletal system, skeletal muscles, voluntary muscles, things that make you really good at running away, the heart and the lungs, because that gets blood flowing and gets oxygen to tissues. It also puts blood into the lower brain centers, which makes you more aware of dangers and makes you want to run more. It especially turns up your heart and lung function too. And this is good in short durations. There's nothing wrong with having a little bit of extra oxygen in your body. That heart is doing something important. However, what it does mean is that there is less blood capable of going to and supplying the digestive organs, whether that's your liver, your stomach, your small intestine, or your large intestine. Now, just to be clear, it's not that there's no blood going to those things. No one could survive that. That would be a very big design flaw. But it does mean over a long enough period of time, over a long enough duration of this sympathetic reaction, this innervation dominance, you get a decrease in some of the normal functions of our digestive system. This includes absorbing the food. So that food that should be coming into our digestive system through the stomach, small intestine, all the way around in there, interacted upon by the liver, and, well, all the other things, and should be bringing in nutrients in this area and bringing them back to the main circulation to be broken down and utilized by the body. There's simply less ability to do that at speed. This is absorption, of course. and it needs to be done at a certain rate. If we don't do that effectively, we don't get cellular fuel properly. And this comes down to everything in the body, plus the digestive organs themselves. If there's not good blood flow in, the cells can't do their job as well. And some of these cells assist in the passage of vital nutrients. On the other hand, too, in a global perspective, if you don't have enough absorption, if you don't have enough cellular fuel for action of the digestive system, this includes the big stuff like the pancreas and the liver, well, you can't get fuel in, period. Over a long enough period of time, you're operating at a loss, no matter how much good food you eat. Ultimately, what this can result in is a loss of the ability to constantly repair. The need for constant repair is, well, constant in the human body because everything is falling apart and everything is rebuilding. It is a exchange, usually, hopefully, in fact, about 1-to-1. Because as soon as we lose some of that ability to repair, we start to see gaps form in the system. Not necessarily holes, of course, that's not what we're talking about, but areas where it's not repairing fast enough. And we might see some extra wear and tear where we normally wouldn't. Now, this isn't a fast process. It takes a very long period of time, but we're operating at a loss. Slight as it may be, the digestive system is simply not capable of repairing itself nearly as fast. This is important. Now, to be very clear on this, the sympathetic system does not equal disease, because the sympathetic system is very important in regulating blood flow at all times. There is a balance between this blood going to the muscle, heart, lungs, and lower brain centers, and going properly to these things, because we're constantly changing where blood goes, and it's essential that we have this sympathetic tone driving the blood flow through this system, making sure not too much gets through, or enough gets through, or not too much gets through to these, or enough gets through to these. It is always changing, always adapting to what you're doing. However, long-term sympathetic dominance does come with its problems, because sympathetics does, in fact, equal stress. And when we're under this stress for long periods of time, we see the faults of this start to come through. Long periods of time, of course. This is not a quick process. And so this is something we need to be aware of. We need to start seeing our fascia as part of our healthcare system, part of our health maintenance system, because it's reactive too. It's assisting in the guidance of blood flow in a way. If it's been given sympathetic innervation from the spinal cord, it must mean it's important that it has it. And so this is why therapies such as, chiropractic, osteopathy, physio, fascial stretch therapy, and even some of the exercise-based therapies that work on alleviating fascial immobility and fascial strain. These are very beneficial to do, or to have done to you in some cases, because what they're capable of doing by balancing out that tissue strain or reducing that immobility is they can cut out some of that afferent input from happening, that excess afferent, which means we don't have nearly as much efferent effect as a result. And this means the blood is better able to be regulated by the sympathetic, not excessively regulated by the sympathetic.